Hello everyone, welcome to today's lesson here for Thursday. Going to go over the answers from yesterday on page 3 that you should have tried, just practicing these drawings of quadrilaterals. And then we're going to go into the notes for today, page 4. Again, I actually, in the packet that I posted online, I put the notes already in there. I wrote them out and decided to copy in there just to try to save you guys a little bit of time. So we'll go over those still. And then we'll do maybe one of the answers for tonight on page 5 together here. I'm going to ask that you try page 5, just the odds after. You may need to do the work on a separate sheet of paper because there's not a lot of extra room there. And that's perfectly fine. Just like the old days, back when I was in school, we had textbooks and we had to write everything on paper. And we walked to school both ways uphill in 4 feet of snow, and we liked it. Does that sound familiar? All right, so here we go. So page 3. So here was your drawings that you should have had last night. Again, you see that the drawings themselves are not perfect. They're sketches, but the labels make them right. So here we have a parallelogram. You notice that you have opposite sides the same. One mark, 2 marks, 2 marks. Opposite angles the same. One arc, 2 arcs, 2 arcs. Parallelogram. Square, all 4 sides the same. All 4 angles 90. Isosceles trapezoid, the 2 non-parallel sides are the same. They have just 1 mark on each one. And then the base angles on the bottom are the same, and the base angles on the top are the same. Right trapezoid, you have 1 leg that makes 90 degrees with the 2 bases. By the way, they call the parallel sides of trapezoids the bases. It's going to be important when we do today's notes on some of the formulas for the areas of these 2-dimensional shapes. Here's a rectangle. Can't quite see it there. Rectangle. Again, all 4 angles are 90, and then opposite sides are parallel and congruent. So these ones are the same length, and these ones are the same length. And a rhombus, we did that yesterday in our notes there. All 4 sides the same. Opposite angles are like a parallelogram. Opposite angles are the same, but not 90. All right, so there's 4 drawings of quadrilaterals. When you guys get into some of the upper level math classes, you'll be using labels like that on some of the stuff. All right. So here we go. Notes on the next page here. Areas of quadrilaterals. Again, quadrilaterals, 4-sided shapes. We're going to also talk about areas of circles and triangles as well. For any of the quadrilaterals, it's some version of base times height. Okay, just multiplying the one side times the other side. Okay, that's what the b, little b times the h stands for. I'm just going to throw this out there now. Later on, we're going to see a capital B. That means something different. That's going to mean when you see a big B, capital B, that's not going to be like the length of a base, which might be like 9 centimeters. Big B would stand for the area of the base. We'll be using that for 3-dimensional shapes later on. So I'm just going to give you a heads up to make sure that you're not using a big B in your formula, because that'll be the area of the base. And those units will end up being things like centimeters squared or feet squared or inches squared, stuff like that. Okay, so little b times little h, base times the height. So let's take a look at some of these examples that I gave you on the page here. Rectangle, pretty straightforward. You've been doing this for a number of years. If I have a rectangle that the bottom is 10 and the side is 7, you could say length times width for a rectangle, or the base times the height. But the height is going to be the distance between the bases. So if I consider 10 to be the base, then 10 would be my other base here. 7 would be the distance between the bases here, and that's considered the height. So 10 times 7, base times height, 70 centimeters. Could you turn it on the side? Turn it on the side, sideways, and then say 7 is the base and 10 is the height? Sure, you could do that, and it'll still give you 7 times 10, which is 70. And for area, the units are squared, centimeters squared, because centimeters times centimeters, centimeters squared. Another quadrilateral you could see would be a parallelogram. You can see how this is just slightly different. And the reason is it's not the 2 sides, it's base times height. So if I consider 11 to be the base here, that means this upper side would be 11 as well. And the height is the distance between the bases. This is a big deal here. So 5, you see how it says 90 degrees here, and they tell you this distance between the two 11s, top and the bottom, the dotted line? That distance is 5. That would be considered the height. Okay, 6 is the other side of my parallelogram, but it's not the one side times the other side, it's the base times the height. So it'd be 11 times 5 here, which is 55 centimeters squared. And then what about the weirdest one yet, the trapezoid here? Trapezoid, okay, you can think of the trapezoid, well, the bases are different lengths in a trapezoid. It's the two parallel sides are the bases. So the solution is, it's kind of like they'd say the average base times the height. Well, how do I take the average of something? Well, if I'm trying to find the class average on quiz scores and I had 20 kids in my class, I would add up all 20 scores and then divide by 20. So you take the number of scores and divide by how many there are. If I have two bases, then I would add up both bases, 10 and 14, which is 24, and divide by the number of bases. There's two of them, so 24 divided by 2 is 12. So here's the actual formula. If you wanted to not think of it as the average base and you just wanted to write down the formula and use that, that's the formula for area of a trapezoid right there that I just bubbled in. Okay, base 1 plus base 2 divided by 2 times the height, which is still the distance between the bases. So they could tell you like this was, let's say, 7 centimeters. It's not going to come into play here because the two bases are 10 and 14 and the distance between those bases is the height, 6. So I plug in the one base, 10, plus the other base, 14. That gives me, when I add them together, 24. 24 divided by 2 is 12, like I said earlier, and then I multiply that by the height, 6. 12 times 6 is 72. So it's the base 1 plus base 2 divided by 2 times the height, or you could think of it as the average base times the height. Alright, so that's it for your quadrilaterals. Square would work the same. It's this type of rectangle. A rhombus would work the same here. Alright, and then you got your trapezoid there. Alright, the other two that we have to work with is the area of a triangle. We'll do next. Area of a triangle. I have the area of a triangle here. Let me move it so you can actually see it. Area of a triangle, the formula bubbled in right here is base times height divided by 2. Base times height divided by 2. Now, one of the ways that you probably never really thought of this, but if the area of a rectangle is base times height, you can see that if I took that rectangle, this is almost like magic now. This is like extra level math teaching today for the same great price. No extra cost. If I draw that in, you can see I split it in half, and this red shape here is a triangle. That area would be exactly half of the original thing. So if the area of the original rectangle is base times height, the area of this triangle would be that base times that height cut in half, divided by 2. And that's where the formula comes from, that the area of a triangle is base times height divided by 2. It's going to work a little bit differently. Like this example over here, this is a right triangle because it was a rectangle, so the base times the height is going to be, again, you're looking for that 90 degrees from the base to say what's the height. If you have a rectangle that's not a right triangle, then they would have to tell you this height of the triangle right there, which is whatever side you consider to be your base. Your height is going to be the 90-degree distance from the base to the opposite vertex, the opposite point across from that base. So that would be the distance considered the height right there. Okay, so I have this, it turns out to be an isosceles triangle because these are both 13, but they give me this distance from 10 all the way up to this top point. So that's going to tell me I'm going to use 10 as my base. The bottom here is base. It doesn't have to be the bottom, but it is this case. And this distance straight 90 degrees from that, perpendicular from it, up to this top vertex, this top point is 12. So that would be my height. So there's my base and my height, 10 and 12. So I plug in 10 for my base, 12 for my height, divide by 2, 120 divided by 2, 60 centimeters squared. And that's the formula used for triangles. And the last example, example 5, to make it easier, because you might not have easy access to a scientific calculator, I'm going to let you leave your answers for all circles in terms of pi for now, so you can leave it with the pi right in there. I did show you both in your notes where this is in terms of pi, this is if you multiplied it out using the pi key. But the formula is simply pi r squared. It's pi times the radius squared. Well, since you can leave it in terms of pi, you pretty much just got to take the radius and square it. Not times 2, but square it. It means multiply it by itself. So in this case, area equals pi times 5 squared. Well, 5 squared is 5 times 5, which is 25. So the area of the circle is 25 pi centimeters squared. Centimeters, because I use centimeters a lot here to try to make things easy and not confuse you. All right, so you have, for all the quadrilaterals, base times height, base times height. If you have two different bases, average base times the height. Your triangle is going to be base times height divided by 2, and your circle is pi r squared. Make sure that before you try page 5, the odds, that you at least have the formulas written down. If you have all the examples written down too, definitely keep this right next to you while you're trying the problems on page 5. Again, I only assigned for you to do the odds, so you only have 6 of them, and I'm going to do one of them with you right now. I guess we'll do the circle here, because it's the first one. Again, you may need extra paper. I'm going to write it in over here. This is a circle, so the first thing I'm going to write down is the formula. Area of a circle was pi r squared. Then I'm going to say, okay, the radius is 6, so I'm just going to replace the radius with 6. So I just got to do 6 squared. Well, 6 squared is 6 times 6. So it's pi times 36. And we typically write the coefficient, the number part first, so I would just rewrite it as my final answer. Area equals 36 pi, and the unit is centimeters squared. So that's my area. 36 pi centimeters squared. Okay, so one of them done. You can see that only took me a minute. And you have a rectangle, which should take you about 10 seconds, a circle, a triangle, a square, and a circle. So this one, you didn't have any trapezoids and you didn't have any parallelograms. This one's actually a little bit easier because those, I think, are the two trickier ones. These are the easier ones. Tomorrow we'll practice where we have a trapezoid and a couple of parallelograms, so that will be a little bit different. Okay, but for tonight, page 5, just finish those other odds, those other 5 problems. Hopefully it goes well, and I will check in with you tomorrow. Have a great day.